All right, so this video is going to go over pages 20 and 21 in your vectors packet. So an aircraft travels at 220 meters per second at 74 degrees north of east. Okay, so first thing we're going to do is we're going to draw this out. Okay, so you know you have to be in the northeast quadrant, so you can go ahead and draw a line that basically goes in the middle of the northeast quadrant. We just got to figure out where that angle line is going to go. So if that last letter is E, that means that is the directional line that you need to touch. So if east is right here, you need to touch that east line. Okay, so that would be your degree right there. So 74 degrees. And anytime I give you a value with an angle, okay, that means that is the hypotenuse that goes with that angle. So that is going to be 220 right there. So what we're going to need to do is we're going to need to break this triangle down into its x component. Okay, so its horizontal component, you can label it whatever you want. I usually just use x with horizontal. And we're going to break it into our vertical component, and I just use y. Okay, so that is part A. Okay, so if I know two sides of a triangle, okay, well, if I know the hypotenuse and the angle, I can find the two sides. Okay, that y is going to be your opposite, and this x is going to be your adjacent. Okay, so if I want to find my opposite, the trig function that uses hypotenuse and opposite is going to be sine. Okay, so we're going to do sine of 74 equals opposite, which is y, over your hypotenuse, which is 220. Okay, again, make sure you are in degree mode. Okay, otherwise you're going to get a weird answer. So my vertical is going to come out to be 211.48 meters per second. And I'm going to go ahead and label that north. Okay, so again, just be careful with this. You can label your triangle as much as you want or however you want to. Okay, but you still need to be able to tell me that this is the velocity that is going purely north. Okay, so now I found that component, so I'm going to find my x. So the trig function that uses adjacent hypotenuse is going to be cosine. So cosine of 74 equals x over 220. Okay, so multiply both sides by 220, and you're going to get a horizontal velocity of 60.64 meters per second, and that is going east. Okay, so that is how you break down a triangle into its two pieces, is by using sine and cosine. So part B, it says calculate the time the aircraft takes to fly 8,000 meters north. So what I've been saying in class is that if you're not doing SOHCAHTOA stuff or Pythagorean theorem, okay, the only other equation that you're going to be using is V equals D over T. Okay, and I can even do the little circle right here. So, and we'll give you this on the test. Okay, so V equals D over T. Now, so we're going to see what we have. So part B, okay, we're going to label our V, our displacement, and our time. Okay, so it says calculate the time. So that means I'm looking for time. So that is your question mark. Okay, for how long it takes to fly 8,000 meters north. So 8,000 meters, that is displacement. So we're going to put that on the displacement. And then north. Okay, so that's where you got to be careful is when I say north, I only want the velocity that goes north. And you've got three options. You've got the 220, the 211.48, or the 60.64 meters per second. Okay, so the only one that goes truly north is that 211.48. So that's going to be my velocity. So 211.48 meters per second. And now I can do V equals D over T. So 211.48 equals 8,000 over T. Okay, so you can switch the T in the 211.48, or you can use this circle method up here. So if you're looking for T, cover up T, and that means you're going to do D divided by V. So we're going to do 8,000 divided by 211.48. And that's going to give you 37.83 seconds. Okay, so part C, it says in the above time. So that means we're going to use the exact same time. So we're going to set up our V, our D, and our T. So our time is going to be 37.83 seconds, which we just found. How far east? So how far, that means you're looking for distance. And we're talking about going east. Okay, so the velocity I'm going to use that's going east is the 60.64 meters per second. Okay, the reason you can't use that 220 is because that's a mixture of both. Okay, if I'm just talking purely east, you can't use the 220 because it's not purely east. So we're going to plug in, so 60.64 equals displacement, we don't know, over your time, which is 37.83 seconds. So we're going to multiply both sides by 37.83, and you're going to get a displacement of 2,294.01 meters, and that is going east. Okay, so that is your answer there. Part D, in the above time, what is the overall displacement? So part D, we're going to do the V, D, and T. Okay, so D is what we're looking for. Okay, we want to know what is the overall displacement. Okay, time is 37.83 seconds. Now, when I say overall displacement, what I mean is I want to know what is the actual displacement of the hypotenuse. I want to know how far that line is. The 220 is not how far it went, that's just the velocity of it. Okay, so we're going to figure out how far that hypotenuse actually goes. So our velocity is now we get to use the actual 220 because that is the overall velocity. That's the mixture of both of them. Okay, so we're going to do V equals D over T, so 220 equals displacement over 37.83 seconds. Okay, multiply both sides by that, and you are going to get a displacement of 8,322.6 meters, and that is going to be 74 degrees north of east. All we're doing is we're just taking that same direction I gave you in the beginning of the problem. So please don't forget directions, because remember, this unit is called vectors. What makes a vector is direction. So you need to make sure you're putting that in your answer. Okay, so that's going to finish that problem. So we'll move on to the next one. Okay, a fighter plane goes into a power dive at 300 meters per second at 53 degrees below the horizontal. Okay, so below the horizontal means if I draw my cardinal direction, you can draw it either way. You can go this way, you can go this way, either one. But below the horizontal means your angle is going to be right below that horizontal line, which is the x-axis. Okay, so my angle is going to be 53 degrees. My hypotenuse is 300 meters per second. That means our triangle is going to look like this. So I'm going to probably have to find my x and probably have to find my y. Okay, so there's your triangle. So A, it says find the horizontal velocity of the plane. That means I just want to find out what x is. Okay, so part A. Now, x is your adjacent. Okay, so I have a hypotenuse, I have an angle. The one that can help me find the adjacent is cosine. So cosine of 53 equals adjacent, which we don't know, over hypotenuse, which is 300. So multiply both sides by 300, and you're going to get a horizontal velocity of 180.54 meters per second. Okay, and I'm just going to label that horizontal. Okay, if you want to label it east, by all means, go for it, as long as we can tell what you're doing. Okay, B, we're going to find the vertical now. So sine is going to help us find our y, because that's the opposite. So sine of 53 equals y over 300. So multiply both sides by 300, and you're going to get a vertical velocity of 239.59 meters per second. And that is, I'm just going to go ahead and label that vertical. Okay, so that way I do not mix that up, because it can be easy to mix those up, so just make sure you know which one's which. Part C, it says the time it takes to drop 2,400 meters vertically. So keyword there is vertically. So we're not doing SOHCAHTOA stuff anymore. We're not doing Pythagorean theorem. Okay, so that means we're going back to the V, D, and T. Okay, so time, looking for time. Okay, drop 2,400 meters, so that's my displacement. And if I'm talking about going vertical and vertical only, I'm going to use the velocity that's going vertical and vertical only. That is going to be that 239.59. Okay, so we're just going to plug in now. So 239.59 meters per second equals displacement, which is 2,400 over t. Okay, so switch the t and the 239.59, so take 2,400 divided by that velocity, and we're going to get a time of 10.02 seconds. Okay, now part D, it says the horizontal displacement, so that means I'm looking for the horizontal distance. Okay, so we're going to set up our V, our D, and our T. Okay, so if I'm talking about going horizontally, that means I'm going to use the velocity that's going horizontal. That is the 180.54 meters per second. And I want to know what is the horizontal displacement, so I don't know what D is. And my time, I already figured that was 10.02 seconds. Okay, so plug in, so 180.54 equals D over your time, which is 10.02 seconds. Okay, so I'm going to multiply those both sides. Okay, multiply both sides by 10.02, and you are going to get 1,809.01 meters. And we're just going to go ahead and label that horizontal. You can say it's east if you want to, either one. So 1,809.01 meters. Okay, E, the resultant displacement. So anytime I say resultant, that means hypotenuse. So I want to know what is the length of that hypotenuse. Okay, so we're going to do our V, our D, and our T. So we're going to use the velocity of the hypotenuse now, so 300. Displacement is a question mark. Time is 10.02 seconds. So we're just going to plug in. So 300 equals D over 10.02. Multiply both sides by that, and you're going to displacement of 3,006 meters. And we're just going to go ahead and say that's 53 degrees because that's the angle, and we're just going to say below the horizontal. Okay, you could say south of east if that one works, if that's what you were using. So as long as you have a direction on there, we're good with that. Number 9 is more conceptual questions. So this is about frame of reference. If two boats pass each other out at sea and there's no land visible in sight, without looking at the waves, is there a way to tell which boat is moving? So think about that is when you look out your window and you see things moving, you can tell it's moving because you're comparing it to something else that's standing still or it's moving. But if you have nothing to compare it to, okay, there's only ocean, okay, you wouldn't actually know which boat is moving at all because you have nothing to compare it to. So the answer would be no, because there is no frame of reference. So there's nothing to compare that motion to. So no frame of reference. And that's it.